Hello, my name's Stephanie Wilson and I'm from SUEZ, where we specialise in water purification systems for laboratory applications. So welcome to episode 1 of our webinar series, where we are aiming to answer all your frequently asked questions around purified water. So this episode is called What is Purified Water? And it will focus on explaining some common terms. The webinar will take around 15 minutes with 5 minutes at the end for questions. You can submit questions in the chat function at the bottom of the webinar screen. So we are aiming to do a webinar series. So other subsequent episodes will focus on different water types, technologies used in the purification process, how to maintain your water system, and the importance of changing your consumables. So if you have any burning questions around purified water, please get in touch, send me an email, and we will cover it in one of our webinars for you. I hope you enjoy. Why is purified water so important and what is it used for? So in the laboratory, laboratories require an inert media for the basis of any sample analysis. They also may routinely measure and test samples for gases, organics, minerals and bacteria, which is why impurities have to be removed. For general lab techniques such as glass washing or making up media or reagents, a lower grade of water is usually required. For techniques such as tissue and cell culturing or PCR, a higher grade and more pure water is required. Laboratory equipment such as glass washers, environmental cabinets and biochemical analyzers also require a direct feed of purified water and are usually directly connected to a water system. What is hard and soft water? So when it rains, water runs through the land and is subsequently evaporated, forming the water cycle, which you can see in the diagram on the right-hand side. If you live in an area where the land has a high limestone content, rainwater dissolves the limestone into calcium and magnesium ions, which flow into the water source. It's this high concentration of ions in the source water that causes hard water. Water hardness can stick to pipes and kettles, producing limescale, which is hard to remove. Hard water also causes problems in water systems, and therefore these minerals have to be removed by specialised technologies, which we will cover in a subsequent episode. Where the land is low in limestone content, it tends to be high in organics and therefore contains low concentrations of ions, which makes the water soft. Organics are long-chain carbon molecules produced from naturally decaying vegetation and fertilisers, which flow into the source water. Organics are also removed during the water purification process. What is conductivity and resistivity? So conductivity describes the amount of minerals dissolved in water, like when you dissolve sugar in your cup of tea. When minerals dissolve in water, they split into cations and anions, and it is these ions that carry charges, which makes the water conductive. The more ions in the water, the higher the conductivity, and conductivity is measured in microsiemens. Resistivity describes the resistance of pure water. So as part of the purification process, minerals are removed, which decreases the conductivity of the water. The greater the degree of purification, the more resistant the water becomes to conduct. Resistivity is measured in megohms. So if you look at the diagram on the right-hand side, 1 microsiemens is equal to 1 megohms. On the right-hand side of the diagram, the higher the conductivity of the water, the less pure the water is as it contains more minerals. On the left-hand side of the diagram, the purer the water, the more resistant it is to conduct due to there being less minerals in the water. So on the right-hand side, the higher the conductivity, the less pure the water is as it contains more minerals. Left-hand side, purer the water, the more resistant it is to conduct due to there being less minerals in the water. What is TOC and why is it so important? TOC is total organic carbon and is measured in parts per billion and parts per million. Organics are long-chain carbon molecules which are found in source water. So going back to the water cycle again, the picture on the right-hand side, if you live in an area where the surrounding land is farmland or marshland, natural decaying vegetation and fertilizers cause high organics in the source water. Organics can also be man-made, and these include pesticides, herbicides, and detergents. TOC can cause problems in water systems and therefore have to be removed by specialized technologies, which again we will cover in a subsequent webinar for you. The lower the TOC, the purer the water. What is the difference between distilled, purified, deionized, and ultrapure water? So purified water is water that has been mechanically filtered or processed to remove impurities. Distilled, deionized, and ultrapure water are common terms used to describe water in different purified states. So distilled, deionized, and ultrapure water are forms of purified water. So if you look at the resistivity and conductivity scale at the bottom of the slide, distilled water is water that has been boiled into a vapor and then condensed back into water, leaving impurities behind. Distilled water is a form of purified water and usually has a conductivity between 10 and 1 microsiemens. The distilling process is time-consuming and expensive. Deionized water is sometimes also called demineralized water, and this is water that has had almost all the minerals removed, such as cations like sodium and calcium, and anions such as chloride and sulfate. This process is performed by ion exchange resins, which is a specialized technology, and again we will cover this in a subsequent episode for you. Deionized water is a form of purified water and has a resistivity between 1 and 10 megohms. Ultrapure water is water that has been purified to the highest level of purity, where all impurities and ions have been removed. Ultrapure water is a type of purified water and has the highest resistivity of 18.2 megohms. So this brings us to the end of episode 1 of our webinar series. I hope you've enjoyed listening to me and that I've answered a few questions that you might have had around purified water. We'll just take about 5 minutes to answer any questions that you have. If you could submit them by the chat function at the bottom of the screen. So we'll just wait a few minutes and see if you have any questions. So I've got a question here. What is the difference between a lower grade and a higher grade of water? So a lower grade of water will have higher amounts of minerals, organics, and bacteria. And for example, it could have a resistivity of around 1 megohms. A higher grade of water will have lower amounts of minerals, organics, and bacteria. And for example, could have a resistivity of around 10 megohms. Anyone have any more questions? Okay. Why do different laboratory techniques require different grades of water? So for general lab techniques, such as glass washing or making media or making reagents, the water isn't actually going into a sample. So for making media and reagents, other components are usually added to the water to make the reagents, which can change the state of the water. So therefore, a lower grade of water can be used. Also, when making media, media is usually made and then autoclaved. So the bacteria content isn't so controlled because all the bacteria will be killed during the autoclaving process. For tissue and cell culturing or PCR, for example, these samples are very sensitive, and so water needs to be of a high purity so that it doesn't contaminate your samples. Any more questions? How would a customer test the water themselves? For testing your feed water, to figure out how hard or soft your water is, you normally submit a sample for feed water analysis, which we can normally help you with, or you can look online at which water company provides the water in your area, and they usually have data on their website for like water hardness and their feed water analysis. There's usually data on their website. How can I test the water to see how well the purifier is working? So usually on water purifiers, on the screen, it usually tells you how high or how low the conductivity or resistivity is of the water that is being produced using your water system. So this is usually just on the screen. To test it yourself, I suppose you could test the conductivity of the water using a conductivity meter. For organics, I'm unsure. So another question there, how do you know how hard or soft your feed water is? So I just mentioned that before, you can submit feed water samples for analysis, which we can help you with, or there might be kind of local laboratories in the area that do this kind of function. Or again, you can look online at your water company provider, and they usually have data on their website. Is it recommended to have a pre-filter before the water supply and the purifier? So this depends on your feed water. So if you think about water kind of around the world, each different country, their feed water will all be of different kind of types. Some feed water might have higher sediment or higher total dissolved solids. So sometimes we would recommend to have a feed water analysis. So we can find out if the water has, say, high organics or high sediment, and then we can figure out if the water needs pre-filtering before it enters the water system. So if you have, say, high sediment, for instance, we might mention that you might need a sand filter before the water enters the water system, so the system doesn't clog with the sand, basically. So again, this will depend on a feed water analysis. Okay, another question. What is the difference between conductivity and resistivity? So conductivity describes the amount of minerals in the water, dissolved in the water. Resistivity describes the resistance of pure water. So removing minerals decreases the conductivity of the water and increases the resistance of pure water. So conductivity and resistivity are reciprocals of each other. So 1 microsiemens equals 1 megohms. So as one increases, one decreases. So lower conductivity is equal to an increase in the resistance of the water. So a lower conductivity means that that it's a higher resistivity. How are organics removed from the water? So the basic technology in water systems is reverse osmosis, and this removes about 99% of bacteria and 98% of minerals and organics. So yes, the reverse osmosis removes the majority of organics. If the water needs to be of a more pure quality, then it's the 185 nanometer UV bulb component, which breaks down organics into charged molecules, and then these are removed by the deionization cartridges. We are going to cover different techniques used to remove impurities. All the different technologies will be covered in a subsequent webinar. So hopefully you can join us again for the subsequent episodes. Does anyone have any further questions? You said that distilled water was not as pure as deionized water. If the customer is using a still, how come there are still ions in the condensate? So you said that distilled water was not as pure as deionized water. Yeah, that's true. If the customer is using a still, how come there are still ions in the condensate? So this is just due to the distilling process. Some laboratories still use distilling technologies to purify their water. It's an old technology, it's very time consuming and expensive. But just due to the distilling process, the boiling and the condensing water back into water, just all the impurities aren't removed using this technique. So deionization and using a water system purifies water to a higher level, basically. So it's just how the technology is used. Okay, so I think that brings us to the end. If you could just take a few seconds just to answer the poll question at the end of the webinar. This is just to shape the content of our future episodes. So if you could just answer the poll question, we would be very grateful. Thank you very much for your time. So if you join us next time for our next episode, this will be understanding differences in water quality. This will give you some information on different water types and their different applications as well. So my email address is there. If you could please register your interest, that would be really helpful. Thank you very much.